Good day to all. Today we can discuss about normal distribution and standard Z score in the subject Foundations of Data Science. So this normal distribution and data science distribution and standard is at score. So it introduces the we are going to discuss about the two core topics in this subject. So normal distribution and this is a score. Understanding is essential before moving into hypothesis testing, confidence intervals, and machine learning, and all of which assume or rely on normality in some form. So we need to study normal distribution and standard is at score as a basic topic before going to learn about in detail about the hypothesis testing. So, what is normal distribution? So, the normal distribution is a continuous probability distribution with the following characteristics. One is symmetric, then bell-shaped, and center around the mean. So, what is symmetric? So, symmetric means the distribution is perfectly balanced around its center point. So, center from this, it will be having a mirror-like images in the right and left half. Next is bell shape. The curve rises to a peak and tapers off symmetrically on both sides. Then centered around the mean means the peak of the curve always occurs at the mean value. So the most and natural real world phenomena we can explain is one is heights of individuals in a population, student exam marks in a large class, measurement errors in scientific instruments, blood pressure readings, everything will be, we can take it as examples for this normal distribution. So it is having certain properties. The first property is a theoretical curve defined for a continuous variable with a symmetric bell-shaped form. So with symmetric bell-shaped form, as I have told you, it is like exactly the mirror image. It should be the first and foremost property of a normal curve. And because it is symmetrical, it should be following the bell-shaped curve with the mean at the peak point, and the right and left half will be having the equal set of data sets. And mean equal to median equal to mode. All these measures should be same for this normal distribution. So because of symmetry, exactly 50% of the data lies below the mean and 50% of the data lies above the mean. So what is the importance of mean and standard deviation while going for this normal distribution? So why we are calling these to be indispensable? Why when working with a normal curve, two values which describes are only one is mean and another one should be the standard deviation, that is nothing but the spread. Without both values, you cannot be able to characterize or use a normal distribution. So what is mean? The mean is the center of the normal distribution. It determines when the curve is positioned along the horizontal axis. So it should be locating at the center. Shifting mu shifts the entire curve left or right without altering its shape. For any mean normal distribution, you will be having the similar value of mean, median, and mode. And the changing mu does not affect the spread of the curve, only its position should be changed. This is what should be the role of standard deviation or the shape or spread parameter. It controls how wide or narrow the bell curve is. It measures the average distance of observations from the mean. Small sigma, small standard deviation represents tall and narrow bell curve. Large sigma represents short and wide bell curve. So it defines the unit in which deviations from the mean are measured. So together, mu and sigma completely specify any normal distribution. These two parameters should be definitely needed for defining a normal distribution. So you can see now one with the normal distribution with the peak value here, and each side will be having the same exact mirror image. Sometimes you have different normal curves. So every normal curve can be interpreted in exactly the same way once any distance from its mean is expressed in standard deviation units. So here we have three different types of normal curve. One with same mean and different standard deviation, some with same standard deviation and different mean, and some with different mu and different sigma. There are three different cases. So the first one, the curves share the same center but different in spread. So larger sigma and smaller sigma will be there. So second category, curves are identical in shape and width, but shifted to different position along the horizontal axis. And the third case, curves differ in both position and spread, yet all retain the fundamental bell-shaped curve. So how many rule can be deviate? So it is an empirical rule, 68 to 95 to 99.7 rule. What it represents is for any, regardless of mu and sigma. So first, it will be if your mean is varying plus or minus 1 sigma, that is 68%, that is actually 68.27, rounded off to 68%. What it represents, 2 by third of all observations fall within one standard deviation of the mean. And the second category, that is the 95% data, that represents the standard mean will be varying from plus or minus 2 sigma, which is 95.45%, that is 95% data. Nearly all data falls within 2 standard deviations of the mean. And the third one will be plus or minus 3 sigma, represents 99.73% of the data. So virtually all data falls within the 3 standard deviations of the data. So here it represents you have 3 and 2. Same standard deviation, different standard deviation. Bell-shaped curve will be the same structure, but it is refers only in the position. So the standard normal curve will be defined as the special case of the normal distribution with mean mu 0 and standard deviation sigma equal to 1. If the original distribution approximates a normal curve, then converting to standard or z-scores will always produce a new distribution that approximates the standard normal curve. So for that is the actual need for going for the z-score with the special case of standard normal curve with mean 0 and standard deviation 1. So when should be the mean 0? The mean of the standard deviation normal distribution is 0 when x is equal to mu into the z-score formula. So z-score is x minus mu by sigma. So here whenever this both are same, it should be deviating. So whenever SD is 1 sigma, you will be getting the value of z should be 1. The standard deviation of the standard normal curve is now always 1. So the standard normal curve allows us to use single published Z table to find areas for any normal distribution. So one or standard normal curve, infinite normal curves. There are two cases. There is an infinite number of different normal curves, each with its own unique mean and standard deviation. There is only one standard normal curve with a mean 0 and a standard deviation of 1. So what is in the finite normal curves? Every possible combination of mu and sigma produces a different normal curve. Each curve has its own shape, position, and scale. They cannot be directly compared without a common reference framework. So this makes a direct comparison across distributions impractical. So this is not at all a feasible one whenever it is going to be an infinite value. Then the second category is standard normal curve, mu 0, sigma 1. That is the actual is a set value. It is represented, preserved after converting to Z score, and one universal table will be covering all possible normal distribution. What this Z conversion does and does not change, converting original Z score preserves the normal shape of the distribution, the curve remains well shaped. So changes the units as well as centers the distribution at 0 and standardizes the spread, the standard deviation becomes 1. So what it represents? The Z score is also called as a standard score or standardized score, is a unit-free standardized score that regardless of the original units of measurement indicates how many standard deviations a score is above or below the mean of its distribution. So it is always actually comparable. There is no unit deviation from the mean and how much whenever it is going to cancel out. So it is actually given the name standard score, standardized score and unit-free score. So Z score has two parts. One is it can be a plus or minus value. So if it is a plus or minus value, what it indicates the direction of the deviation from the mean. Positive sign means the score is above the mean. A negative sign means the score is below the mean. So what is the magnitude or number represents? It indicates the size of the deviation in standard deviation units. For example, 2 means the score is 2 standard deviation away from the mean. So here I have given 3 examples. One is Z is plus 2. What is that represents? It is represent above the mean direction. The original score is exactly 2 deviations above the mean of its distribution. And if it is Z equal to minus 1.27, the score is exactly 1.27 standard deviation below the mean. And the Z0 represents at the mean. The original score is identical to the mean. It coincides exactly with the center of the distribution. So this interpreting Z scores practically is how does the student's score compare to the class average. So Z greater than 0 means above average. Z less than 0 means below average. So example we can score. So practically for medical testing, finance, quality control, we are going to use this Z score. So this data science normalizing features before applying machine learning algorithms. For that purpose, we need this Z score. So Z score are the foundation of many statistical tests, including one sample Z test, two sample Z test, and the standardization step in Gaussian based machine learning model. So this normal distribution and Z score, without getting this knowledge, we can't move to the machine learning algorithms. So what are the things we have discussed? We have discussed about the normal distribution. What is normal distribution? There are the Z scores basics. Then what is the characteristics of normal distribution like symmetry, bell-shaped and continuous distribution with mean equal to median equal to mode. Then we discussed about mean and standard deviation. What is mu locates the center, sigma contributes the spread. Then we have discussed about the different normal curves. Infinite normal curves exist all for following this empirical rule 68 to 95 to 99.7 rule. Then other standard curve, standardized curve. Then Z score formula we have discussed. Then Z score examples. So this Z score examples will be with the different variations like 2.2. And what will be the case, whether it should be above the mean or below the mean or at the mean. So this is about the basics of normal distribution and Z score. So hopefully you have understand this. Thank you.